horizontal and vertical asymptotes of the curve y equals 5 plus x cube all over x minus x cube. So horizontal asymptotes means the limit of the function when x goes to plus infinity and when x goes to negative infinity. So we need to evaluate two limits. So let me just find when x goes to infinity. So that is, so we are finding HA, horizontal asymptote, 5 plus x cubed over x minus x cubed. Then to evaluate this limit, we always divide top and bottom by the highest exponent of x, which is x cubed. So x going to infinity, so divide top by x cube, bottom by x cube as well. That means 5 over x cube plus x cube over x cube. So 5 over x cube over x cube. On the bottom, x over x cubed, which is 1 over x squared, because x over x cube means one copy of x cancel from top and bottom. Okay, so just 1 over x squared minus x cube over x cube 1. Now when we take this limit, 5 over very big means it's going to be 0, 1 over very big means 0, so 1 over negative 1. So this is pretty much negative 1. So horizontal asymptote is y equals negative 1. So, and we need to see what happens when x becomes very small. But since this is a rational function, means a polynomial divided by another polynomial, regardless of x going to plus infinity or negative infinity, we get the same value. So there is only one horizontal asymptote. So y equals negative 1 is the only horizontal asymptote for this function. Now let's find vertical asymptotes. That means x values for which the function goes to infinity when we approach from left or right. So looking at the function here, our function is fx or y, same thing, 5 plus x cubed over x minus x cubed. We want to see where this function is undefined, okay, and see for those x values, unless we get 0 over 0, those values will be vertical asymptotes. So the bottom x minus x cube is 0 where? Okay, we can solve this. Factor x out, 1 minus x squared equals 0. Now we can factor further. In fact, 1 minus x squared is a difference of two squares. So that's 1 minus x, 1 plus x equals 0. Oh, we are getting 3x values. So x equals 0 from the first factor. 1 minus x 0 means x equals 1. 1 plus x 0 means negative 1. So for these 3x values, this function is undefined. Now we need to check before we declare they are vertical asymptotes. If the top also becomes 0 for any of these values, if we get 0 over 0, that's not a vertical asymptote. That will be a hole on the graph. So when we plug in 0, the top is not going to be 0. So x equals 0 is a vertical asymptote. Plug in 1. If we plug in these three numbers on the bottom, we are getting 0. I'm just checking if we get 0 on the top as well. If we get 0 on the top as well, the x value is not a vertical asymptote. So 1 not going to be 0, negative 1 not going to be 0. So vertical asymptotes are all three. So x equals negative 1 is smallest, then 0, and 1. That means these are the x values, or we can say a. All that means when we take the limit of this function as x approaches to any of these three values, negative 1, 0, or 1, I want to write a, then this function is going to go to plus or minus infinity. The function increases without bound, okay, from one side. If we approach from both sides, the function, the limit might not exist. In either case, these are vertical asymptotes.